So, Bill, why don't you introduce yourself to us briefly? Kind of what's your role? What do you do at Facebook?
Sure. Hey, everyone. Good afternoon. My name is Bill Jia. I'm coming from Facebook. Um, I manage two major teams at Facebook. The first one is software and hardware performance engineering and capacity. The second team is hardware validation. So whatever we push into OCP, then we get hardware from ODMs. Then eventually one of my teams take all the hardwares and run all kind of validation work to make sure all the hardwares can run into production very performantly and very reliably.
So would you say, in a way, your team's the biggest consumer of OCP probably today?
Yeah, we buy like billions of gears, billions of dollars, US dollars gears from OCP every single year.
Awesome. And then Aaron, can you introduce yourself for us?
Yeah, I could just say I have a lot of the same function at Rackspace that Bill does at Facebook. I run Rackspace's infrastructure strategy function, which works on new platforms that we bring in and works with our engineering team to sustain our existing ones. So whenever we bring something new in through Open Compute, my team is the first that works on it, and then we roll that into a central sustaining group, and it's performance and data center operations and integration and testing, just like what Bill said.
Excellent. So I think Bill will start really being the largest consumer of Open Compute gear and having your team really kind of the fundamental consumer base. What have you guys learned? What's been the experience with OCP, kind of going back to the very beginning? What things do you feel have been really good?
Well, yeah, thank you. It's a very good question. It has been a very long journey. I joined Facebook in 2009, and by then, the team I led is primarily buying servers from OEM, right? From OEM. Then it was not very bad experience. It's pretty good. We buy a lot of gears from OEM. We ship all the gears to the data center, and it runs in the data center very smoothly. And we get very good support, and we pay money for the OEM. Everything runs. Everything runs very, very well. Then one day we feel like, hey, Facebook infrastructure is really like going in a very hyper growth mode. Then we start to think about, hey, how can we start to look at all our products, whatever products you name at Facebook, like from web tier, database, caching tiers, search, newsfeed, video and photo, analyze all these product features, then kind of think about, hey, how can we design hardwares in such a way so that our software can benefit the most, right? And at the same time, we can cut off all the vanity features in the hardwares. So by doing so, we can cut down a lot of cost, and also the hardwares can run very beautifully with software, with the product as well. Then we also design our own data centers, and we design our own networkings. So the hardwares and the software, data center and powers and networking are all working in the same ecosystems in a very globally optimal way. So by doing this, and we cut down the cost, more serviceability from data center tech ops point of view, then networking and power consumption is all getting better in general.
So from a Rackspace standpoint, I know that they led the charge and kind of launched the project, but you guys were in really, really early. What's been the driver? And then subsequently the experience to get involved?
Yeah, well, Joel, you'd know better than anybody. Just a little inside joke here. Joel got us started with Open Compute. I remember talking with him saying, I don't know if this is such a good idea. Maybe we should just stick with what we've done. This looks like a big, hard distraction. And then Joel left, and I got to pick up his work. Our experience with it has actually been really positive. If you have seen the Racco X product line here at Quanta, that was a lot of work between Rackspace and Quanta in our very first designs and deployments to take what was in Open Compute and adjust it just a little bit for our data centers. We straddle this weird spot between hyperscale and enterprise, and it's the nature of our product set and our business. So we really feel the kinds of drives that hyperscalers have, but some of the additional operational complexities that enterprises deal with. And what we got out of it most, and what I began to appreciate and then really feel empowered with, was the extra influence that I had over product operations and product development for our infrastructure at Rackspace. That initial time period feels a little nervous, and the ramp feels a little odd, and you have to make a couple of investments that you wouldn't normally make running an infrastructure environment. But once you get that well integrated, it just feels so much better running infrastructure that way, because you have so much more control and influence. At least that's what we had than we had with our traditional partners that we bought from.
Cool. You both represent teams that buy a large volume of gear at a pretty heavy pace. When you think about a broader market, a space where OCP originally maybe isn't meant for every single consumer, but is certainly meant to kind of set the basis for what hardware could look like for a much broader user base, what do you guys feel like would go really well from a broader market consumer base, and what do you guys feel like maybe we need to make some progress toward to improve that experience or that dynamic? It could be technical, it could be supply chain, really whatever you guys are kind of seeing as large users.
Yeah.
You go first?
Sure, I'll go first. I think over the years, if you'd asked me in our first year, I'd have given you a different answer than today. Supply chains were definitely more complex in open compute in the early days, but nowadays, I mean, just look at this facility and look at what Quanta is doing, and it's really quite rich by comparison. It's much easier to onboard yourself into open compute today than it was years ago. And that goes for systems management and repair and replacement and system integration and all kinds of other things like that. So I think nowadays the challenge is just basically deciding to make that leap. I think within open compute, when I think about it, that's the big focus right now, is getting people to give it a trial run. I think once you do that, you discover that you know what you need to do. It's not so mystical anymore. And most people that we talk to, once they get started, they don't really think about going back. They like it.
Sure. I also start from supply chain. I think supply chain for sure has been a big challenge for open compute, because when we buy stuff from OEM, then hey, we need more gears. Just send order to the OEM. Then second, maybe in like few weeks, start show up. Right? For OCP, typically this is how Facebook does things. Typically we forecast all the demand on a quarterly basis. Then we send orders to ODM on a quarterly basis. That also means all the gears can show up in the data center on a quarterly basis. So it worked for us because our volume is huge, and we can buy buffers to absorb any uncertainties. But on a broader market space point of view, it's much harder for other players. One thing we're thinking about is by working with ODM in the future, instead of buying on a quarterly basis, change the model into a buy stuff on a monthly basis. There's a lot of challenge we have to solve, but in general, we're pushing towards that model. That's number one. Number two is, of course, hardware validation is a challenge, because we're not buying stuff from OEM, we're buying stuff from ODM. Then we actually established a very solid hardware validation team within the company and test everything from end to end. Make sure everything can go to data center in a very reliable way and performant way. For this, for the general market space, that also can be a little challenging.
Gotcha. In fact, that leads me to another question. If you think about what a consumer would need to kind of have in place, or where they might need to invest internally to adopt open compute effectively, kind of what would you look at there? And I know maybe it's changed over time, so we could kind of comment, at each phase. Are we looking at team dynamics? Are we looking at new tools, new software? What is the major functional impediment that you would look out for, maybe historically and today, if you were trying to make that transition?
Yeah, I think I'd start with what Bill talked about in terms of thinking about how to buy. You hear the phrase rack scale. Open compute really works best, I think, if you're buying and deploying, thinking about the rack as your unit of capacity at a minimum. And if you're thinking forward about your data center and your applications as pools of capacity that you need to manage, then you can begin doing that forward-looking sort of forecast and analysis work. And once you start buying and thinking that way, it's a lot more attractive than buying servers in small buckets and doing customized hands-on deployment of them. But that is a shift, and the sorts of resources that you need and the way that your applications and your IT teams need to think is just a little bit different. Again, I think it's something you have to try before you can really get into it, but it gets easier. Different, I think, perhaps than Bill, maybe because of how we operate and how we do business, at least with Quanta. I don't think hardware validation in AVL is as difficult for us as it once was. In fact, at this point, I think it's pretty straightforward. For us, if you look out on the floor, you can see all kinds of Linux distributions. You see Microsoft, you see VMware, and there's a fairly rich set of components that you can put into these systems that have been pre-validated. So, just like any server, we still occasionally find problems in those systems, bugs that we need to chase down within their life cycle, but I don't actually consider it to be all that much different than any of the systems we were buying from some of our original manufacturers.
Cool.
Yeah. So I want to pick on the hardware validation. So one thing the team at Facebook right now is thinking about is in terms of hardware validation, we can somehow separate into two different tiers. One tier is very built in-house, and it's very tailored towards Facebook internal products. From, hey, look at all the web tier traffic, caching tier traffic, database traffic, look at all the write and read, all these characteristics, then do the hardware validation exactly based on this kind of workload. So that's very in-house, so we can get accuracy up to 99%. However, that's very in-house tiers. Then we also want to build one tier, which is the open house tiers, which is look at all the industry. Typically, what kind of workload a typical company will experience. Then based on this, then every single tier we can also define maybe multiple different permutations. Then based on this, then we can develop certain kind of industry standard benchmarking tools. Then by building these tools, then we can do this within house. Then we can get all the benchmarking results within maybe 10 to 15 minutes. At the same time, because of those industry standard, we can actually release all these tools to whoever wants to adopt. So that's actually we can do the blanket coverage at one shot.
That's a hugely exciting area. I mean, what's the status now of kind of the beginning to canonize those testing tools and some of those results frameworks so that other people could rely on those? Is that underway? Is that forthcoming? Kind of what do you see there?
I think we're making very good progress. We have already working with certain vendors to do this. Of course, based on different workload, some things can be more difficult than other things. For example, if we want to test the CPU or memory or flash card, that could be more easier than if you want to test on networking or storage. Mm-hmm. Right? So that's we're making progress.
That's awesome. I'm really looking forward to that one. To me, that's been something that honestly I've wanted since, I apologize guys, since the very beginning. Embarrassing.
Somebody heard about calling you.
Yeah, somebody needs some overcompute gear, huh? So, that said, I think one thing we were talking about before we came on stage, which was pretty interesting to me, is you have a variety of platforms, and I think you guys have really worked to kind of right-size the platform dynamic so you can work all the way across the stack. So rather than having something that's overbuilt, you've moved all the way down and actually drugged Xeon D to market in many ways. So looking at that and kind of hand in hand with your performance engineering and some of those benchmarks, how do you feel like other consumers can adopt with confidence who might not have that kind of degree of understanding about what their workload is or what their environment needs to do? And this is to both of you.
Yeah. I actually suspect you're going to get two very different answers. Go ahead, Bill. Go ahead.
So one thing I was thinking, I was thinking about Facebook. So Facebook has many different products, while other companies may not have. However, so hardware right now is open source. It's OCP. It's open source. It's OCP. At Facebook, however, on the software stack, we're also very big proponent on the open source as well. So we are using, let's say, standard memcache as caching layer. We're using MySQL as open source, very much open source tools, and we're using HBase we're using Hadoop, we're using HHVM and Presto. It's all open source tools. One thing we're thinking about is, so if we can inject, if we can combine the software and the hardware together, then make that as entirely open source stack, then industry can benefit a lot from that experience.
That sounds really exciting. So Aaron, what are your thoughts?
Yeah. So some of our software is very homegrown, and it suits itself well to broad scale development that you can open source. OpenStack being a prime example for that, and a lot of applications that exist in the OpenStack world. But we also run a lot of applications that are very common, maybe a little bit have a little bit longer legacy, a little bit more difficult to shape into the hardware. And my perspective on that is very much if you just looked at the configuration of a server from an open compute platform to anything else, they do tend to have the same processors, the same networking components, so you can often think about them the same way. But one area where I think we are maybe different here, or where we're leaning forward a little bit, is as we come to the end of challenges with if we come to the end of Moore's Law and we start looking at how to squeeze more out of our servers when the chips are not necessarily delivering, we start to enter into a new space in our terms of our systems management and how we process data that really makes this software-hardware integration an industry challenge that we will all share. And I think that part is very much different. And at least up front, if you see what Facebook's done with OpenBMC and what we've done working with OpenBMC, you start to see us crawling into firmware stacks and much tighter control over the components. But doing it in a way, I think, as Bill is saying, that is easy for other people to begin to get involved with. And I think that represents a new frontier. I think over the next few years, we'll benchmark differently. Some of our applications will be sort of built and started on this notion of a very new kind of infrastructure that will make life very interesting for our system administrators and our designers and so forth. I think exciting in new ways, but also bring some new challenges along when you can't just get your next boost right out of the processor like you used to. You may have to get your acceleration from interesting new kinds of memory or storage or processing elements.
Very cool. Actually, there's one thing I really want to talk about. We got 2 minutes, so it's not going to leave much. But from a management standpoint, we've kind of seen Open Compute come in early with a very different story than we have today, and things like OpenBMC honestly add a whole new dynamic. Kind of as you guys look at it from a user standpoint or an adoption standpoint, what do you feel like needs to be added to the stack? Where do you feel like it needs to expand? And understanding we've got a minute and a half to cover that one. So,
maybe go for it. You go first.
Yeah. For me, I think what I want to do is, especially in the systems management stack, say at this point, servers have all the elements that you need in Open Compute to do systems management if you want to do it in a very traditional way or in a newer way. What we're sort of telling our developers to think about going forward here is that BMC component, those other parts of the server, now that it's open source and it's more accessible, it's all programmable. So we tell our system administrators, it's an app. It's someplace where you can write an app. So if you want to build your own management framework, you can do that on top of that BMC. It used to be this thing you couldn't see or touch or control, and now you can. And that takes a while for them to get used to, but once they get started, they kind of find their way to their own productivity and extra value.
that one's awesome. Is your team using OpenBMC now?
We do. So OpenBMC, this management interface towards the server side, which is very cool. In the meantime, we also build certain kind of management functionality into the rack switch level. Mm-hmm. Then additionally, we also build the management tools to monitor entire data center power consumptions.
Okay.
So by observing the power consumptions from every single servers and also every single server's networking traffic, then we can communicate all this message up one layer into networking layers. Then one level up into the data center power and cooling management systems, so that we can control the entire servers, networking data center in a holistic way.
That's awesome. Honestly, it's an honor. I could spend 2 hours here talking to you guys about this stuff. Thank you very much. And that's all our time.